Hi guys, welcome to another maths lesson with A+ Tutoring. I'm Tanuki and today we're going to be looking at 5 grade 9 NAPLAN-style word problems. If you haven't already, please check out the word problem lesson video linked in the description. Essentially, that was a lesson where I went through a step-by-step process for breaking down word problems. If you have already watched that lesson, please keep watching. Okay, let's look at the first question. As always, pause the video here and take a chance to read through the question or even have a go, and then we'll get to it. Okay, let's go through the question together. The ratio of boys to girls in a class is 3 to 5. If there are 24 students in total, how many boys are there? Okay, again, we've just gone through and highlighted. Let's try and understand what's going on now. So we're working with ratios, and we're being told that this ratio here is boys to girls. We're being told that we've got 24 students in total, and we're being asked to figure out how many boys are in the class, right? So with any ratio, 3 to 5 essentially means, like if we add the 3 to 5 together, we get 8, right? So we've got 3/8 of the class are boys, and 5/8 of the class are girls. We're being asked to figure out how many boys there are, so we just need to focus on this fraction. So 3/8 times 24, remember, because we've got 24 students in the class. Cancel this out. 8 goes 3 times. 3 times 3 is 9. So our answer is 9 boys. Pretty straightforward question. Let's move to the next one. Again, pause the video here and take a second to go through it or just read through it. Either way, pause the video here. Okay, now that you've had a chance to go through the question, let's dissect it together. A shirt priced at $80 is discounted by 15%. What is the discounted price? Okay, what are we trying to buy here? A shirt. We know that the shirt is priced at $80, but it's been discounted. When you get a discount, are we increasing the price or decreasing the price? Decreasing, right? So it's been decreased by 15%. And what are we being asked to figure out? The discounted price, right? So this is the original price, and we're being asked to figure out the discounted price. So to figure out the discounted price, we need to figure out 15% of $80 and then take it away from that original price, right? So 2 steps to this question. So figure out 15%. 15%, it's always like the best kind of rule with any of these questions is always to turn that percentage into a fraction. And we know that any percentage is basically that number over 100. To make your life easier, you can go ahead and simplify that fraction. So that means we need to ask ourselves which number goes into both the numerator and the denominator. In this case, 5 goes really easily into it, so we just cancel that, make that into 3, so 5 goes 3 times, and divide 100 by 5 as well, it gives you 20. So again, we've just simplified, right? And we know that 15% is the same as 3/20ths. We're not done yet. All we've done is just converting a percentage. What we have to do now is figure out how much we're discounting the shirt by. So figure out what 3/20ths of the price of the shirt, which is $80. Now we need to figure this out. So easiest thing to do, cancel the zeros out. And then we know 2 goes 4 times. 3 times 4 is 12. Right? Is this our answer? No. This is what we've figured out here is just the discount, right? What are we being asked to figure out in the question? The actual price after the shirt's been discounted. So the discounted price equals the original price take away the discount, which means the original is $80, take away 12, which is 68. So it's pretty decent discount on a shirt. Okay, let's go to the next question. Again, pause the video here and have a go at the question. Okay, now that you've had a chance to go through the question, let's break it down. Question number 8. Calculate the volume of a cube with side length 6 meters. Very straightforward question. What are we being asked to figure out? The volume of a cube, and we know that the side length is 6 meters. Cube means that all sides have the same length, and that's why we've been given this piece of information, right? Cube is just like the 3D version of a square. Squares have equal lengths, same with a cube, equal lengths. To make your life easier, I've actually provided a diagram of a cube here, but again, you won't be provided a diagram in every single circumstance, so make sure you know that you can sketch out a cube really quickly, draw it for yourself, and then use a visual to kind of guide your working out. I'm not going to label every side 6 meters, but just know it in your head that every single side is 6 meters on this cube. Now, what are we being asked to figure out? The volume. Right? How do we figure the volume out? In the case of a cube, so in any other shape, it would be like length times height times width, something like that, right? Because the side length is 6 meters, you can just go like length times length times length, right? It's going to be the same number. And we know that each of these sides are 6 meters, so it's 6 meters by 6 meters by 6 meters, which means it's 36 meters by 36 meters squared by 6 meters, right? What we're doing here are index laws, which we haven't covered as much yet, but yeah, 36 by 6. 6 times 2 is 18, plus 3 is 21, so it's 216 meters cubed, right? Or cubic meters. So what I mentioned there, they're index laws. That's why your meters is being cubed. You might be familiar with it, you might not be too familiar with it. Either way, that's how we would present our answer. Cool. Next question. Okay, very similar question again. Pause the video here and take a second to try it yourself. Okay, let's go through it together. Find the total surface area of a cube with side length 3 meters. Okay, we're not working with volume now, we're working with total surface area. We're still working with a cube, but the side lengths are 3 meters now, so 3 meters like that, yeah? Total surface area. Think of it as, like, if you imagine like a dice that you play with in like a board game, all the sides that you can touch on a cube, we're figuring out the area of those sides. So essentially we're working with the faces. So faces like this, right? Face like this, face like this, right? All the way around, essentially. So the first thing to figure out the total surface area is to understand how many faces a cube has. So if you were holding particular dice in your hand, how many of those faces would touch your hand, like as you roll it over in your hand, essentially, right? So easiest way to think about it is we've got four sides around going around like that, and then we've got like a roof or the top, and then we've got the bottom, right? So four all around and two top, bottom. So we've got six faces, right? The next part is to understand the area of a single face on a cube before we try to figure out the total surface area. So essentially, total surface area would be 6 times the area of one face, right? Because we can just figure out the area of this top face, for example. We know that we've got 6 of these on a cube, essentially. So we've got 6 times, how do we figure out the area? If I draw this out, that top face is 3 meters by 3 meters, right? So the area would be length times length. So it would be 3 meters by 3 meters, which means 6 by 9 meters squared. 6 times 9 is 54, 54 meters squared. That's your answer, or 54 square meters. So with any total surface area question, it might not always be a cube, you might get a prism, you might get a square pyramid. Just think of the sides that you would be able to touch with your hands if you're holding that 3D shape, and then think about the different shapes on that, like different 2D shapes almost on that cube, and then figure out the area of each of those first, and then add it together or multiply if you've got the same faces going around. Okay, question 10. Last question for today. Pause the video here and have a go first. Okay, now that you've had a chance to go through the question, let's break it down together. A train travels at a constant speed of 80 kilometers per hour. How long does it take to cover a distance of 200 kilometers? Okay, let's dissect it. So we know we're dealing with a train. We know that it travels at a constant speed. What does constant speed mean? The speed doesn't change, right? It'll stay at a certain speed throughout the journey. And we know that particular speed is 80 kilometers per hour. What are we being asked to figure out? How long? So when we're thinking how long, it's the amount of time does it take to cover a distance of 200 kilometers. So how long, how much time is it going to take to cover 200 kilometers when we're traveling in this train, right? So we know that the train travels at 80 kilometers per hour. That's the speed it's traveling at. What are we being asked to figure out? How long it's going to take to cover 200 kilometers. So essentially, if it's 200 kilometers, how much time, right? So sometimes it not be easy to go straight, oh, what do I need to multiply 80 by to get to to get to 200? So in that case, we can change this, what we're working with here, to something that we can manipulate a bit better. So 80 kilometers for 1 hour, right? If we're dealing with 20 kilometers, then how long is it going to take? A quarter of an hour, yeah? Because we're dividing this side by 4. We need to divide this side by 4. So 1 hour becomes a quarter hour, or 15 minutes. But it's better to stick to hours because then you don't have to do as many conversions and you're not dealing with different units. So stick to an hour and use fractions. What are we being asked to figure out? How long it's going to take to travel 200 kilometers. To go from 20 to 200, we're multiplying by 10. So we need to multiply this side by 10. Right, so a quarter times 10. It's the same as 10 over 4, right? And we can change 10 over 4 into a decimal. So let me get some more space around here. 10 divided by 4. 4 goes 2 times. Take that away. 4 can't go into 2, so you put a decimal point, bring a 0, goes 5 times. So to travel 200 kilometers, we would be using 2.5 hours, right? So our answer is 2.5 hours. Couple of moving parts there, but it's just about understanding the numbers, changing numbers that you can work with them, and learning to use one particular unit throughout the question or throughout your working out.
I hope this helped you tackle word problems like a pro. Don't forget to like, comment, and subscribe for more lessons. See you in the next video.